Greetings of the day, dear students. In this video, we are going to discuss about the applications of the operational amplifier. What are the different applications we are having, like inverting amplifier as an integrator, differentiator, summing amplifier, and difference amplifier. In coming videos, we will discuss in detail the step by step all the applications of the operational amplifier. In this video, we are going to discuss about the inverting amplifier, right? And also its circuit diagram, its operation, and some small analysis part, how to calculate the gain of the inverting amplifier, where we will get it as ACL equals to V output by V input equals to minus RF by Rin. This is the gain we are going to get. These things we are going to discuss in this video. Coming to the inverting amplifier, this is nothing but a normal opamp in which the output is given as the feedback to the inverter terminal of the input with the help of a feedback resistor. This is very important. If you observe some part of output, again at the output we have taken again one more resistor, the feedback resistor RF, which is connected again to the inverting terminal of the op-amp. If you recollect the previous basics, this is the negative terminal indicates the inverting terminal and the positive terminal represents the non-inverting terminal. Now at positive terminal, let the input voltage be V1, and at the negative or inverting terminal, let the voltage value be V2. Now the difference of this voltage is going to get amplified. If you observe, with respect to the input, a resistor R in is connected in series with the input, and at this node point, at some node X, at the point where you have connected the feedback resistor RF, at that node you just indicate with the variable X. Now once this V1 is at potential, is already at the ground potential, right? Now the difference in between this V1 and V2 is represented with the variable Vd, right? Now for analysis sake, what we do is we will assume that this V2 is also at ground potential. This is very important. While doing the analysis part of the inverting amplifier, at node X, the potential is assumed to be the ground potential, right? Now because of the high input impedance offered by the operational amplifier, what happens is no current should flow through this operational amplifier. No current should flow through this operational amplifier. Now whatever this input current is flowing through Rn, it should flow through this forward feedback resistor Rf. Now what could be the value of input current? What will be the value of input current? That is we are going to calculate now. So the assumption we made is the node X is at ground potential. The node X will be at ground potential. Now if you observe from this diagram, the input current will be simply the input voltage divided by R input resistance, Rin. So it indicates the input resistance. The assumption we made is assume Vd equals to 0. That is the node X is already at ground potential. Now if you observe the output voltage, what will be the output voltage? Simple, the current flowing through the feedback resistor, which is nothing but the input current. The entire input current is flowing through the feedback resistor Rf. So minus I into I in input current into Rf. Already we have found out I input, the input current is nothing but V input by Rin. Therefore the output voltage is equal to the minus V input voltage into Rf divided by Rin. Very important. Then what about gain? The gain formula we already know. The gain of an inverting amplifier is given as output voltage by input voltage. Output voltage by input voltage. Therefore, so here the ACL, the gain of the inverting amplifier is nothing but minus Rf by Rin. Very important. If the input resistance is very low, the gain will be very high. Minus Rf by Rin. Now This the same thing can also be done in the alternative manner. If the voltage at node X is Vx, then it can be we can apply the KCL at that node point. It will we are going to get it the current as Vx minus V input by R in plus Vx minus V output by Rf equals to 0. Right now, since the node Vx is at ground potential, which is a virtual ground, Vx equals to 0. Based on that, we will get ACL. The gain is V out by V input, which is nothing but RF minus RF by RN, minus RF by RN. Clear? So dear students, this is what all about the inverting amplifier. Out of this entire discussion, the key point is here we used to connect a feedback resistor RF, which will be connected to the inverting terminal, inverting negative terminal of the op amp. The part of output, from the output we used to get connect a feedback resistor RF to the inverting terminal minus. And another important assumption is at this node point where you have connected the feedback resistor RF, at that point let that be the node X, and the difference between V1 and V2 be the 0. And also this op amp is going to offer high input impedance. Whatever the current that enters should not flow through the op amp, and it flows through the feedback resistor RF. Based on that, this is at voltage V in and this is at zero potential. Now the current is input current is simply given by I in. I input is given by V input divided by R input divided by R input. That is important. Of course, the output voltage will be the current flowing in this direction and minus IF into RF. Output voltage by input voltage will give us the gain, right? In the next video, we are going to discuss about the integrators, differentiators, summing amplifier, differential amplifier. All those things will be discussed in the separate videos. Thank you.